In this video, before we dive into the world of limits in calculus, we need to start with something more basic. Now I'm talking about functions. So what is a function? A function is like a machine. You give it an input, say the number 2, and it gives you exactly one output. Not two outputs, always just one output for each input. Think of it like a vending machine where you press a certain button and you always get the same snack. So it is different from relations because a relation is just a set of ordered pairs like x, y. It can have multiple outputs for the same input. A function is a special kind of relation. For every input x, there must be only one output y. To check if a relation is a function, you can use the vertical line test on the graph. If a vertical line touches the graph more than once, then it's not a function. Now, an example of a relation would be the following ordered pairs. We have 2, 5, 2, 7, and 3, 9. Notice that for the input 2, we have two outputs. It could be 5 or 7. So this is not a function. So what is an example of a function? Let's say we have Engineer Clydes, yours truly, and I have only one partner, my QDPI. So this is a function because for one input, I only have one loyal output. Now let's also talk about Rumi. So Rumi only has one partner who is Ginu. Now when we talk about relations, then it would be like Gerald Anderson, who has multiple partners. He is notorious for this. So we have Gerald Anderson is to Kim Chu, Bea Alonzo, Julia Barreto, and so on. The list goes on. So this is what you call a relation. Now going back to functions, recall that a function is a certain law of correspondence. It is generally associated with a formula. As an example, consider the formula for the area of a circle. So we know that the area of a circle is equal to pi multiplied by the radius squared. Now for each value assigned to r, or the radius, there corresponds a certain value of a. We therefore say that the area of a circle is a function of the radius, and in symbol we write a is equal to f of r. If there is a relation between two variables x and y, such that for each value of x, there corresponds a value of y, then y is said to be a function of x. So symbolically, we write this as y is equal to f of x. Now the concept of functions may be extended to relations between more than two variables. Consider the equation z is equal to f of x and y. For example, the volume of a right circular cylinder is a function of the altitude h, or height, and the radius r of the base. So we say that the volume is a function of the radius and the altitude, or height. So in physics and mathematics, it is important to be familiar with the functional notation because it helps us translate real-life problems into mathematical functions. So let me demonstrate how to set up a formula showing the functional relation between certain variables. Let's say we have to express the perimeter of the rectangle as a function of the length x of one side if the area is 6 square inches. Now let's first define area and perimeter. The perimeter is the total distance around a shape. So let's say we have this rectangle. So imagine that this is a garden. If you walk along the edge, starting at one corner and tracing the entire boundary, then the total distance would be the perimeter. So in this case, let's label this side as x. And then this longer side, let's label it as the length. Now we write this in cursive because if we write L as a straight line, then it would just look like 1. Now we want to avoid ambiguities and confusions when we are solving problems. So we write L as a cursive letter. Now how about the area? The area doesn't care about the edges, but it cares about what's inside. It tells us how much space the shape covers. Now instead of a garden, try to imagine this as a basketball court. And then if we are to paint the basketball court, let's say purple, then the amount of paint we need to cover the surface, this would define the area. So this purple color. So if our area is 6 square inches, then that means that the entire space inside this rectangle covers 6 squares, each 1 inch by 1 inch. So we can now divide this. Let's say we have 6 portions, each with an area of 1 inch by 1 inch. Just imagine that this is symmetrical. But 6 inches is quite absurd for a basketball court, so realistically, perhaps this is just a miniature. Now in this example, we are told that the area is fixed, which is 6 square inches, but we are allowed to change x. The length of one side may be changed, but that would also mean that the length would change. But regardless, we still have the same area. But just referring to this figure, we know that the area of a rectangle is equal to the base multiplied by the height. Or in other books, it would be the width multiplied by the length. Now take note that these quantities may be used interchangeably. So our width is x, and we have our length, x multiplied by L. This is our area. Now we know that the total area must be equal to 6 square inches. Now equate this to x multiplied by L. And then since we want to express the perimeter as a function of x, then we can define the length as 6 divided by x. So we would have L is equal to 6 over x. We just divide the two sides by x. So now, solving the perimeter, this would be the sum of the sides. So 2 sides of x, this would be 2x. Then 2 sides of L, we have 2L. Expressing L in terms of x, we have 6 over x. Therefore, the perimeter is equal to 2x plus twice of 6 over x. Now notice that 2 is common, so we can factor it out. The final expression of the perimeter would be 2 multiplied by x plus 6 over x. So this is now the perimeter as a function of x. So we will tackle more problems in our next video, and then our reference for this would be Feliciano and Ui's book.